So today I'm gonna be doing the Born-Haber cycle of calcium oxide. So first of all, we need to know like the charges, the the charges of the elements, like the energy of the metals and the metal and the non-metal. So the metal calcium has a 2+ charge, and non-metal oxygen has a 2- charge. And I already wrote the balance reaction here. So it's calcium in its what is that called, the standard state, which is solid. You can find that in the periodic table, as well as the standard state of oxygen, which is gas. It's also in the periodic table. And then the result that would be the product that would be calcium oxide solid, but I balance it with 1/2 since we only need 1 O, as you can see here, for calcium oxide. But essentially, by doing the Born-Haber cycle, which are base, which are base, that was some practice that I had there, but which essentially our base is calcium oxide, and we're gonna in order to like get this, this is a reaction we're gonna try to get this to this, and lastly the last step will be like get the lattice energy. But in order to get all that, since there's a lot of steps to go through, so the first step will be the enthalpy change of formation. Enthalpy change of formation, so like breaking both the calcium and the oxygen results in breaking the calcium oxide results in the product side of the equation. So that's what we're gonna write down. So since it's an exothermic process in the Born-Haber cycle are shown with an arrow that's downwards. And when it's endothermic, the arrow is gonna go upwards, and you're gonna see more in a little bit. So now we're gonna put this is the enthalpy formation. Okay, so then you have calcium solid plus 1/2 oxygen gas. So you can either, let's do it this way. So the first step that I'm gonna do now, it's turn this calcium solid to calcium gas, since we have to have both elements in gas form for this diagram, for like the whole process. So like basically Born-Haber cycle requires that like the elements that are in the reaction, they need to be in the gaseous form. Gaseous? I don't know. So therefore we're gonna go through a process of sublimation, which is essentially the process of transforming like an element from solid to gas. So it's an endothermic process, so the arrow is gonna point upwards. So here then it will be calcium gas plus 1/2 oxygen is already in gas, so we don't need to that state because I already in it. So now the next step is gonna be, it's already in the gas state, so let's get it to this charge, so like 2+ charge. How do we do that? We're gonna do that through ionization energy, which is essentially removing electrons from a neutral atom, or it can also be an ion. But so that is, I believe, yes, it is. I think it's an endothermic. No, yeah, it is. It is an endothermic process, since we're removing electrons. So, oh wait, it's not working. Okay. So since an endothermic process is gonna go upwards, and now we're gonna have calcium plus gas plus 2 gas. Okay. But it's not yet in the charge that we wanted to. That was just adding removing one electron. So we need to remove another one in order to get the state that we want. Oh, I'm sorry, I didn't put the sublimation. And this one is the, sorry. This is the ionization energy. Ionization energy. I think I'm missing something. So this is the first one, and this is the first one, and it's for, yeah, that's what it was. Okay, so now we need to do another one, and putting the arrow is gonna be, so I don't forget. So this station energy is gonna be the second one. So now we're gonna get calcium 2 plus gas plus 1 half O2 gas. Okay. Well, that's a little spoiler. I don't know if y'all can see that, but okay. Whatever. So what's next is essentially we already achieved this. So now let's do the changes for the oxygen. Well, the oxygen, as you can see, we only need one O. So in order for us to go from 1/2 O2 to just to choose O, we need to do the bond dissociation. So like the process of bond dissociation, which is essentially breaking the bond. So that's also an endothermic process. So of course it's gonna stay the same. Plus, and this is gonna result now in just one O, as we want it to be. We're gonna stand this. So this was association. So like this pretty much BDE. So what's next is already know, but we need the charges. But this is different. It's not gonna be ionization energy, since ionization energy is it's essentially removing electrons. What we need now is adding electrons. So that's gonna be the process of electron affinity. Sorry, I'm sleepy, but electron affinity. So, oh wait, also we're gonna have to do 2, as you can see. So, electron affinity, this is, okay, wait, no, I should have done that. Like this. Okay, electron affinity, the arrow is going down. Since it's exothermic, so it's gonna be calcium 2 plus and plus O minus gas. Okay, right? But essentially, it has to be noted that the second electron affinity, procedure for oxygen, it's gonna be endothermic. So why would that be? It's because like it's just like adding an electron to an already like negative charge, like ion. So like this requires energy, since it's like it's an electron. You're adding an electron to a negative, like already negative ion, so like there's gonna be repulsion. So thanks to that, that's why it requires like energy to overcome that repulsion. But in the other one, it did not, like it was exothermic because it was coming from a neutral atom to adding an electron, so like there was no repulsion. What was I doing? Okay, sorry, I was like going through that explanation, but yeah. So now this is gonna be, oh my god, I keep forgetting to put the like the little signs to specify like the process that I'm going right now. So this was the first electron affinity for oxygen. So this is the second one, electron affinity for oxygen, and then it's 2 plus, oh, what am I doing? Okay, gram plus oxygen 2 minus gas. Okay, so oh no. Okay. Oh, I didn't select it all. Oh. I'm so embarrassed, but I need to move this. Okay. So we already achieved the equation that we wanted to. So the last step will be the lattice energy. So where is it? Here, we're like back to start, beginning. That's essentially gonna be lattice energy for this. And I believe I am not missing anything else for the diagram. So yeah, pretty much like the last step will be the lattice energy. So like the metal, which will be calcium, and then the non-metal oxygen, they're gonna be finally combined, both in the gaseous forms and the charges, in order to get now the solid that's calcium oxide. So that's gonna release energy. It is exothermic, it's going down, that's why the arrow is going down. And yeah, I think that's pretty much it for the diagram. So let's do like a little recap. So therefore you first for the solid that you're gonna do the Born-Haber cycle for, you need to like know the charges. In this case, for the metal and the non-metal, like identify that, and then like write your valence reaction, and then write the reaction that essentially give you the solid, like what you're gonna do, like your Born cycle, what you want to get, pretty much. So then first step, you do the enthalpy change of formation, then the sublimation, which is solid to gas. So in this case, of course it was calcium because the oxygen was already in gas form. So then you need calcium in the charge that you want to, and since it's a positive charge 2 plus, you're going to use ionization energy, which is essentially removing electrons, so it's going to make the element positive. So it's calcium 2 plus. You have to do 2 in order to get 2 plus, which is it's just different. It's like compared to the I think it's NaCl Born-Haber cycle. Na is only Na plus, so it's only one ionization energy, but here is 2 since it's K, like Ca2 plus. So then you only need one O for the oxygen. You have here 2 since it's diatomic. So then you're gonna use the bond dissociation energy. So you're gonna break the bond. So like so it's an endothermic process. So the air is gonna go up. So all endothermic process here are gonna go with an arrow going upward, and then when they're exothermic, the air is gonna go down. Okay, so then you already have your calcium in 2 plus, and then your oxygen there, but you need the charges. So this is gonna be different. It's not gonna be in first ionization energy. Now it's gonna be electron affinity. Since it's essentially what is that called? Like adding electrons. So it's gonna be, the first one's gonna be exothermic, and then the second one's endothermic. since, as I mentioned before, the repulsion and then the lattice energy as a last step. Since you're combining the metal and the non-metal here, which is going to release energy, exothermic process, the arrow is going downwards, and then that's the end for this. I hope this helped. Thank you.